In 2008, Congress confirmed that a single nuclear detonation could disable America's power grid for months. They hardened every military base. They told civilians nothing. The Pentagon spent billions shielding its own electronics. The device that protects yours costs under $2 in materials. It takes 15 minutes to build. Today, you get the exact build. You get the missing ingredient most tutorials skip, and you get the frequency test that proves it works. But before we build it, you need to understand what you're actually defending against, because it's worse than most people realize. This channel exists because critical survival knowledge shouldn't be gated by cost or clearance level. We don't gatekeep, we don't drip feed. If the information is real and the solution is practical, it goes here. Subscribing isn't about fandom. It's about making sure the next piece of suppressed knowledge actually reaches you. That's the deal. Let's start with what the government actually found and what they did about it. In 2004, the Congressional EMP Commission published its first major report. This wasn't a fringe think tank. This was a commission mandated by the United States Congress, named commissioners, federal funding, a formal mandate to assess the threat of electromagnetic pulse attack on American infrastructure. Their finding was blunt. A single nuclear weapon, detonated at high altitude over the continental United States, could cascade into nationwide grid collapse. Not a regional blackout, not a temporary disruption. A systemic failure across interconnected power infrastructure. 4 years later, in 2008, the Commission published its second report. And this one was worse. Estimated recovery time wasn't days, it wasn't weeks, it was months to years. They spelled it out. See, the large custom transformers that form the backbone of the American grid are not manufactured domestically in significant quantity. Replacements come from overseas. Lead times stretch into years under normal conditions. After a pulse event, with global supply chains disrupted, those timelines collapse into uncertainty. The Commission recommended civilian hardening guidance. They said the public needed to know. They said practical protective measures should be disseminated. That guidance was never issued. Meanwhile, military hardening proceeded on schedule and on budget. Every critical defense installation received electromagnetic shielding upgrades. Continuity of government facilities were protected. Communication nodes were protected. Command infrastructure was protected. You were not. Now here's what matters for the build. The electromagnetic pulse from a high-altitude detonation arrives in 3 phases. E1 is the fast spike. It hits in nanoseconds. It's the component that fries microelectronics, circuit boards, processors, anything with delicate semiconductor pathways. E1 is what kills your phone, your radio, your solar charge controller. E2 is similar to lightning. Existing surge protection can handle it in most cases. It's the least threatening phase. E3 is the slow wave. It's a magnetohydrodynamic pulse that rolls in over minutes. E3 is what overloads power grid transformers. It induces massive currents in long conductors, power lines, pipelines. Anything that stretches for miles becomes an antenna. This distinction matters. A single-layer Faraday cage handles E1 reasonably well. Metal reflects the fast electromagnetic spike. But E3 requires something more, and that something is the ingredient most people miss. We'll get to it in a moment. So the government solved this problem for themselves. Now let's talk about why the civilian solution costs $2 and 15 minutes. Everything you need for today's build is right here in this video. But if you want to go deeper, the Vault has the full Congressional Commission PDFs. It has military shielding specifications from publicly available defense procurement documents, extended gear priority lists, frequency-specific testing protocols, grid-down communication plans, no filler, no fluff. Just the source documents and the extended research behind every video on this channel. Stay here. Today's build is complete and self-contained. The Vault is for people who want the library behind the lesson. Now, the physics. Why does this specific design work when most Faraday cage tutorials fail? Every tutorial you've seen probably shows a single metal container. An ammo can, a trash can, a metal bucket with a lid. Wrap it in foil, seal it with tape, and call it a day. That approach handles part of the problem. Metal is a conductor. When an electromagnetic wave hits a conductive enclosure, the wave induces currents in the metal surface. Those currents generate an opposing field. The wave gets reflected. This is basic Faraday cage physics. Michael Faraday demonstrated it in 1836. It's not debatable. It's foundational electromagnetism. But reflection alone has 2 critical weaknesses. First, any gap in the seal bleeds signal. The lid of a trash can is not a hermetic electromagnetic seal. There's a rim. There's a contact surface. Every imperfection in that contact is a slot antenna that lets energy through. The higher the frequency, the smaller the gap needed to compromise the cage. Second, reflection doesn't handle the E3 component effectively. The slow magnetohydrodynamic wave doesn't behave like the fast E1 spike. It requires absorption, not just reflection. This is where ferrite enters. Ferrite is a ceramic compound containing iron oxide. It's used in every electromagnetic interference suppression component in modern electronics. Those little cylindrical lumps on your laptop power cable, ferrite cores, they absorb electromagnetic energy and convert it to trivial heat. This is established materials science. It's in every EMI suppression textbook. Ferrite-loaded silicone sealant does two things in this build. It absorbs electromagnetic energy that the metal alone would only reflect, and it creates a continuous conductive absorptive seal at the lid joint. The weakest point of any Faraday cage becomes the strongest point in the nested design. The nested design itself mirrors the principle behind military-grade shielded enclosures. MIL-STD-1-80-8-1-20-5 is the military's own hardening standard for EMP-protected facilities. The core principle is layered shielding, multiple barriers, absorption between reflective layers, continuous seals at every penetration point, two galvanized steel trash cans, one inside the other, ferrite sealant between. Two reflective barriers plus an absorptive layer, sealed at both lid joints. This is the military principle, scaled down to commodity materials. The military pays contractors millions for this principle. Here's what it costs you. Commercial EMP bags sell for $50 to $150 each. Pre-built Faraday containers run from $100 to over $300. The EMP preparedness market is growing. Industry estimates put it in the hundreds of millions of dollars. There are companies whose entire revenue model depends on selling you shielding products at enormous markup. The nested trash can cage costs under $2 in added ferrite sealant, if you already have the cans, the cardboard, and the aluminum tape. Even if you buy everything new, you're looking at well under $40 for a cage that holds dozens of devices. Here's the economic reality. Galvanized steel is a commodity. Cardboard is a commodity. Ferrite silicone sealant is a commodity. Aluminum tape is a commodity. You cannot patent this assembly. There's no proprietary formula, no recurring subscription, no replacement cartridge, no app-connected monitoring system, no company profits from telling you to do this. Simple, unpatentable solutions don't get advertising budgets. That is why this knowledge stays obscure, not because it's classified, not because it's secret, because nobody makes money when you build it yourself. Now, before I show you exactly how to build this, I need to be honest about what it can and can't do. If you're still here, you're the kind of person who wants to know what actually works, not what sells. That's who this channel is for. Subscribe so the next one finds you. Here's the truth about limitations. This cage protects what's inside it. Period. It does not protect your house wiring. It does not protect your car's electronics. It does not protect your solar panel array or anything plugged into the grid at the moment of the pulse. If the grid goes down, your stored devices work, but only if you've also stored the means to charge and power them. That means a solar charge controller and lithium batteries go inside the cage alongside your devices. They're on the priority list for a reason. One more thing. The AM/FM radio test I'm about to show you is a strong field indicator. It demonstrates effective shielding across consumer RF bands. That is what matters for civilian protection. But it is not a calibrated MIL-STD measurement. I'm not going to pretend a trash can in my garage is a Pentagon certified installation. It's not. What it is a practical, testable, effective shield built on the same physics the Pentagon uses. That distinction matters. I respect you enough to make it clearly. With that understood, here's exactly how to build it. Materials: 2 galvanized steel trash cans. The smaller one needs to fit inside the larger one with a gap of at least 1 to 2 inches on all sides. Cardboard: enough to line the entire interior of the smaller can and its lid. 1 tube of ferrite-loaded silicone sealant. You can find this at electronic supply stores or online. Search for ferrite EMI sealant or ferrite-loaded silicone. 1 roll of aluminum tape. Not aluminum foil, aluminum tape with conductive adhesive. Step 1. Line the interior of the smaller can with cardboard, sides and bottom. Cut a piece for the lid interior as well. This insulation prevents your stored devices from making direct contact with the metal. Direct contact can create a discharge path. Cardboard breaks that path. Step 2. Place your devices inside the lined smaller can. We'll talk about what goes in there in a moment. Close the smaller can's lid with its cardboard liner in place. Step 3. Place the smaller can inside the larger can. Center it so there's a gap on all sides. That air gap between the 2 metal layers is part of the shielding geometry. Step 4. Apply a continuous bead of ferrite-loaded silicon sealant around the entire rim of the outer can, where the lid meets the body. 1 continuous bead. No gaps, no breaks, no skipped sections. This is the most critical step in the entire build. The seal must be continuous. Every millimeter of gap is a potential entry point for electromagnetic energy. Step 5. Press the outer lid down onto the ferrite bead. Then seal the joint with aluminium tape over the ferrite. Press it firmly. The tape provides a secondary conductive seal over the absorptive ferrite layer. 2 barrier types at the most vulnerable point. Step 6. Test. Turn on an AM/FM radio. Tune it to the strongest local station you can find. Set the volume high. Place it inside the inner can. Close the inner lid. Close the outer lid over the ferrite seal. Listen. Complete signal death. No static. No faint signal. Nothing. The radio goes silent. Step 7. Repeat with a handheld two-way radio. Transmit on VHF. Transmit on UHF. Or have someone attempt to reach you across multiple frequency bands while the radio sits inside the sealed cage. Full spectrum blocking. Confirmed across every consumer frequency band that matters. Now, what goes inside? Prioritize these items. Hand crank emergency radio. This is your link to information when the grid is gone. No batteries required for basic operation. AM, FM, and weather band reception. Spare prepaid mobile phone, charged. With contacts stored locally. Cell towers may or may not survive, but regional infrastructure could recover in patches. Having a functional phone gives you the option. Small solar charge controller. This is your power recovery device. When the sun is your only energy source, this converts it into usable electricity for your stored devices. Lithium batteries, fully charged. Stored energy that bridges the gap between the event and solar recovery. USB drives loaded with survival reference documents, first aid protocols, water purification methods, local maps, family documents, copies of identification, knowledge and identity preservation in a device smaller than your thumb, LED flashlights with electronic drivers. Modern LEDs use driver circuits that an EMP would destroy if unshielded. Protected inside the cage, they give you reliable light without grid power. Total added cost for the ferrite sealant if you already have the cans and cardboard sourced freely. Under $2. When you close that lid, you've just done what the Pentagon did for itself and never told you how to do. Congress documented this threat in 2004. They confirmed its severity in 2008. All military assets were protected with billions in taxpayer funding. Civilian guidance was recommended by the Commission and never issued. 18 years of silence. Not because the information was classified, because it was simply never delivered. Today, in 15 minutes, with $2 in materials, you closed that gap yourself. You built layered electromagnetic shielding using the same physics the military uses. You tested it on camera across multiple frequency bands, and you now understand exactly why it works. Not because someone told you to trust them, because the science is testable and the results are audible. Send this to someone who doesn't know. That's not a slogan, it's the whole point. This knowledge was public the entire day it was published. It just never reached the people it was written to protect. Next week, we go deeper into grid-down communication. Specifically, which frequencies survive, which devices are worth shielding, and how to build a communication plan when every cell tower within 200 miles is dark. That full protocol is already in the vault. The information was never secret, it was just never delivered, until now.